This lesson is on inverse functions. Inverse is not a new word to us. If you recall, we've used the word inverse when we've talked about solving equations, like x plus 5 equals 10. We use something called an inverse operation to undo the addition that's happening and solve for x. So an inverse is basically something that does the exact opposite of what our original does. To start off our notes, let's begin with the definition of function that you saw back in Math 1. And a function is a relation in which every input has exactly one output. Normally when we talk about inputs, we talk about x's, and the outputs are the y's. So there are several ways to represent these. One way to represent a function is with a set of ordered pairs. So we could have the ordered pair 1, 2, and 2, 3, and 3, 2. The inputs in this relation are 1, 2, and 3. And if you notice, 1 is paired with exactly one output, 2 is paired with one output, and so is 3. Another way you've seen this represented sometimes or heard it said is the x's don't repeat, so you can see that that happens here as well. Another way to represent a function is with a table where we have inputs and outputs in the table, and you could use any values you wanted to, positive, negative, fractions, decimals, anything you want. As long as every input goes with one output, you're good. A third way we've seen this represented is with a mapping diagram. In this mapping diagram, we have our inputs in one column, or one bubble. So we could have 2, 3, and 4. And each of these values can go to just one other value. So 2 can only go to one number. 3 can only go to one number. 4 can only go to one number. Notice all three of these went to the same number. That's okay. The thing that cannot happen is we cannot have one number in the input going to several different things in the output. Another way we've heard these described is with airplanes. If these numbers are our airplanes, 2, 3, and 4, then the airplanes can go to the same place. Let's say they're all going to Orlando, the 1. But I couldn't have airplane number 2 go to Orlando and Las Vegas at the same time. So it's okay for several airplanes to go to one place, but you can't have one airplane going to several places. And that's kind of analogous to our mapping diagram here. Finally, the last way that you've probably seen these represented is graphically. And graphically we use something called the vertical line test. If I can draw a vertical line anywhere on the graph of a relation, then that relation is a function if the vertical line only touches the graph at one point. So now that we reviewed functions a little bit, let's talk about what the inverse of a function is. We talked about how an inverse is doing the opposite operation sometimes. In a function, the inverse is the relation obtained by reversing the inputs and outputs. So we're going to switch around our x's and our y's. Just a quick notation information. The f with the little -1 here, this is function notation. Sometimes you may remember seeing f of x to represent a function. Functions can be written as f of x. The inverse of a function can be written as f with the little -1. The way we read it is f inverse of x. So that's basically just the inverse of the function. Now, the next thing we're going to do is discuss how to find the inverse of a relation. So we see these ordered pairs here. I'm going to do a couple of them with you and let you do the others. In this first one, it says, is the relation a function? So if you look at the x values here, do any of them repeat? And if so, do the repeating x's go with the same value? Well, none of them repeat. So this is definitely a function. Now we have to find its inverse. To write its inverse, we just reverse the ordered pairs, putting the outputs first and the inputs second. So y is first, x is second for all of the points. And then we ask ourselves, is the inverse a function? So in this situation, we're looking at our new x's, 4, 5, 6, and 7. Notice that none of them repeat either. So is the inverse a function? Yes, it is. Now let's try another one of the problems like this. We'll do the one right below it. And this one has 2, 4, 4, 8, and 8, 8. Is the original relation a function? Well, look at the x values, all these inputs, and notice how none of them repeats. So yes, this is a function. Now, is its inverse a function? First of all, let's write down what the inverse is by reordering our ordered pairs, putting the x's first and the y's second. So this is what we end up with. And now if you look at our new inputs, the 4, 8, and 8, we do have repeating input values. The 8's repeat. And that's okay as long as the input is paired with the same output each time. And as you'll notice, that is not the case here. So is the inverse a function? No, it's not. Try the other two. Now we have another definition. This one says, if a function has an inverse that's also a function, it is called 1, 2, 1. That means every one output has one input and vice versa. Every one input has one output. So if we go back and look at the two examples we've done already, notice that the first one that we did was 1 to 1 because the function or the original is a function and its inverse is a function. The second one we did was not 1 to 1 because while the relation itself was a function, the inverse was not a function. So this one is not 1 to 1. Let's fill in the rest of this information here. Next it says if we want to find the graph of the inverse of a function. The inverse graph is a reflection over the line y equals x. Now in this line, remember we have slope-intercept form, y equals mx plus b. You'll notice that the slope of this line, the coefficient of the x is a 1, and the y-intercept, which is added or subtracted, is a 0, because there's nothing added or subtracted here. So we have that graphed over here on our coordinate plane, and we also have the graph of a parabola, or what looks like it's a parabola. So to sketch the inverse, the first thing we're going to do is get some points from our original function that's graphed here. In this parabola at -3, I'm going up to what looks like a 7. So -3 is paired with 7, so I'm going to write that in my table of values. 0 is paired with 1, and +3 is paired with +7. So to sketch its inverse, what we're going to do is we're going to take all of the y values that we had here, and they become our inputs. And when we graph them, we'll make them x's. And we take all of the inputs and we make them outputs. And when we graph them, they'll be our y's. So now we just graph each of these new ordered pairs on our coordinate plane to see what we'll see. So here are the 3 points that we put in our new t-chart. And now I'm just going to draw in to connect those. And you should notice that if I folded the original graph over the line y equals x, it would look like our new graph. And that's what every inverse should do when we graph it. So, once we've plotted the inverse points and sketched a graph, we need to decide if this is a 1-to-1 function. So we ask ourselves, was the original table an example of a function? Yes. Was the original graph an example of a function? Yes. What about our inverse? Was the inverse table an example of a function? Nope. And neither was our inverse graph. So is it one-to-one? No, because both the inverse and the original have to be a function in order for it to be one-to-one. Using the graph of the function, the original one that we have here, I can determine if the function is one-to-one using the vertical line test, which we've seen before, and also the horizontal line test, which we haven't seen, but it probably makes a lot of sense to you what it is. So, vertical and horizontal line test. If we try the vertical line test on our original function, we see that it does pass. So it is a function to begin with. But then the horizontal line test is just drawing a horizontal line and seeing if it touches one or more points. That horizontal line touches 2 points, which means our inverse is not going to be a function, just as we discovered. So if it passes the vertical and horizontal line test to begin with, it's going to be a one-to-one function. Now let's talk about how to find the inverse algebraically. To find the inverse algebraically, we've got a few steps. The first thing we're going to do is replace f of x with a y. So I'm going to do this in this example over here. So I've got y equals 3x plus 2. The second thing we're going to do is switch our x and our y. So I'll take my x that's here and put it where the y is. I'll take my y that's here and put it where the x is. So we just switch places on those. The next thing we do is we solve for y. To get y alone, I need to subtract 2 from both sides. So I get 3y on this side because 2 minus 2 is 0. And on the other side, I get an x minus 2. I also need to divide both sides by 3. And I end up getting y equals x minus 2 divided by 3. That's one way to write it. There's other ways to write it as well. Now, the last thing, which didn't really have a step for it, but we do need to change it back to function notation. So what we do is replace this y with an f inverse of x. So just trade out so that we have the proper notation, and we're done. Alright, so that's what we're going to do on these examples down here. And I'm just going to pick a few of them. I think you can do the first two because we just did one like it. But on the next line down, we've got some that are a little bit different. So let's look at those. In this problem, on the second row, on the far left, we have to follow those steps. We're going to trade the f of x with the y. Then we're going to switch the x and the y. So I have x equals y squared minus 3. Then I'm going to solve for y. So I'm going to add 3 to both sides. And then, to get rid of the squared, the inverse operation is taking the square root. But a big thing that people forget is that when I take the square root of both sides, I need to have a plus or minus in my answer. So I'm going to have plus or minus the square root of x plus 3 equals f inverse of x. Now, if you were to graph the original function and this new one, you should see that they're a reflection over the line y equals x, just like we discussed a little while ago. Let's do the one right next to it. Change your f of x for a y. Switch your x and your y. And then solve for y. Now I can't subtract 3 from both sides until I get rid of this square root. To get rid of the square root, we're going to square both sides. And I get x squared equals y plus 3. And now I'm going to subtract 3 from both sides, which you can probably do in your head. And we get x squared minus 3 equals f inverse of x. Now what about this third one over here? In this one, same first step. We're going to switch out our f of x for a y, and then we're going to switch our x and our y. Now by now y'all have probably picked up on the fact that I could probably do those two steps as one, and that's fine if you do that. To solve for y in this problem, I first have to make it so the entire side is not divided by 2, just like I had to make it so that the entire side was not square rooted over here. So to undo division, I'm going to multiply both sides by 2, which gives me 2x equals y plus 7, and then I'm going to subtract 7 from both sides, which gives me 2x minus 7 equals f inverse of x. So if ever you see an entire side having something done to it, you have to undo that before you can do anything else. Let's try this one on the next line as well. Replace your f of x with a y. Switch your x and your y. And then, whoops, did y'all catch that? I wrote x again. Then we have to solve for the y. So in this one, I'm going to add 3 to both sides, giving me x plus 3 equals 1/2 y. And then to undo the multiplication by 1/2, I can either divide by 1/2 or multiply by the reciprocal, which is 2. So you can write this as y equals 2 times x plus 3 in parentheses, or you can write it as 2x plus 6 equals f inverse of x. Alright, so that gives you a good taste of the different types of problems you'll see here. We'll look at one more before we wrap this up. In this last one, h of x, we're going to follow the same steps, and we will get y equals x squared plus 5 divided by 8. We'll switch our x and our y, and we'll get x equals y squared plus 5 divided by 8. Because the entire side is divided by 8, I've got to undo that by multiplying both sides by 8, which gives me 8x equals y squared plus 5. Now I subtract 5 from both sides, and I get 8x minus 5 equals y squared. And now I have to undo the squaring by taking square roots. But don't forget, when I take a square root, I have to do plus or minus. So my final answer for this one will be plus or minus the square root of 8x minus 5 equals, in this case, it would be an h inverse of x. So give the other problems a try, see what you get. Solutions for those will be posted for you, and please feel free to rewatch the video or ask me questions in class if you have any questions. Thanks.